Hello everybody, welcome to this video on statistics. And this video we'll be going through random variables, probability distribution, binomials, and variance. What is a random variable? A random variable is a variable that could have different outcomes. It is called random not because it is actually random, but because we do not know what's coming next. There are two types of random variables, one being discrete random variable, another being continuous random variable. If you do not know what discrete and continuous data are, we already made a video about that, and I'm gonna put that into the description. And so in this video we're going to be talking about discrete random variables a lot and not much about continuous random variables. Let's get into probability distributions, since that's related to discrete random variables. So what is probability distribution? Before we know that, we have to know the meaning of basic terms. A capital X is all the possible outcomes of something. Let's say a die, for example. All the possible outcomes of a die is a capital X. It's usually shown with a capital X. So in this case, with the die example, all the possible outcomes are 1, 2, 3, 4, 5, 6. The X, a small x, is the actual outcome. So after you roll the dice, the outcome that comes out is X. So capital X is 1, 2, 3, 4, 5, 6. X could be 3, for example. And P in brackets X is the probability of one of the values in the one of the values of small x, the actual outcome, actually occurring. So let's say 3. In this case, in our die example, it doesn't matter which number, the probability is 1 divided by 6. So what is a probability distribution? A probability distribution is a list or a graph showing all the possible values of a discrete random variable along with their probabilities. Let's take this picture as an example. I'm going to show you an example real quick. We are going to be counting the number of cars passing through this junction every minute. We're going to then make a table out of the data we've collected. So in this example, the capital X here is 0, 1, 2, 3, 4, 5. So there's a chance that 0 cars will pass through a minute, and there's a chance that 5 cars will pass through a minute in each. So, and everything in between, all the numbers in between too. And yes, decimals are not included, which is why they're called discrete random variables. So the first minute, after counting the number of cars going through the junction in a minute, is 1. The second minute is 3. Oh, by the way, when I say the second minute, it's not actually the first minute plus the second minute. It's actually another minute of its own. So in the second minute, which is also 60 seconds, which is also just 1 minute, but the second time we are measuring, 3 cars pass through. Third minute, 0 cars pass through. And we keep doing that, but as many times as you wish. But remember, you have to think of how many times you're going to measure and collect data like this. You can't just keep going and stop when you're tired. You actually have to think. I thought of ending at the 10th minute, and I collected data till the 10th minute. Now let's count how many times each of these numbers occurred. So how many minutes did 0 cars pass through? Or how many minutes did 1 car pass through? There were 2 minutes or 2 times when 1 car passed through a junction, 2 times when 0 cars passed through a junction, 3 times when 2, 2 times when 3, 1 time when 4, and 0 times when 5. So there wasn't a single scenario or a single minute where 5 cars passed through a junction. Now we have to find the probability of 0 cars, 1 car, 2 cars, or each of these numbers over here actually occurring. So to find that, we have to take this number right here, or this 2 for example. We have to take how many times the cars were seen in a minute, so the numbers I just showed here, divided by the total number of minutes, which is 10 in this scenario. Then we have to make a probability table or distribution, and it'll look something like this. So 0 cars pass through. The probability is 20% because it's 2 divided by 10. So 20%, 1 car also 20%, and so on. So we have just created a probability table right here. Now let's get into binomials. Before we get into the topic, let's take a quick breather here. Okay, Billy. Okay, guys, let's continue with binomials. What is a binomial? A binomial is a random variable that has two outcomes, like yes, no, heads, tails. But be aware that these two outcomes are either heads or not heads. It's never, not heads is basically tails, but it's never going to be heads and tails. It's always heads and not heads, which is basically like success and not success. It can be the other way around depending on what you do, depending on what you're doing, like tails and not tails, which is not success and success. But it's always success and not success. It's never heads and tails. It's always heads and not heads. These are all the questions that have the answer to these questions must be yes in order for a discrete random variable to be considered as a binomial. Are there fixed numbers of trials? Does each trial have two possible outcomes? Is the probability of success the same for each trial? Each trial must be independent. Or must are each trials independent? What I mean by each trial must be independent is after getting the results of one trial, after conducting experiments or whatever with one trial, the second trial must not be affected by the first trial. What I mean by are there fixed number of trials is, let's say you're rolling a dice or flipping a coin. How many times are you going to be flipping the coin? How many times do you know? You have to think of how many times you're going to be doing that before you actually even start the whole binomial, before you even start experimenting or before you even start doing the trials. You have to know how many times you're going to be flipping the coins. For like n is what you represent it with. So n is equal to 10 means you're going to flip the coin 10 times. What do I mean when I say does each trial have two possible outcomes? That's what a binomial is. Binomial does have two possible outcomes, but there is one exception. It's not exception, but it's, you might think that this example which I'm going to give you right now does not have two possible outcomes. Let's say you're rolling a die. You might think the die has six possible outcomes, but what you're recording is one and not one. So you're trying to get a one. It's either getting a one or it's either not going to be one. The chance varies. So the chance of getting a 1 is 1 out of 6, and the chance of not getting a 1 is 5 out of 6. But although there are more than 1, although there's 1, 2, 3, 4, 5, 6, it's always going to be 2, but it's still two possible outcomes. What do I mean when I say is the probability of success the same for each trial? Let's say that this is a group of people, and 5 of them like dogs, and 5 of them do not like dogs. And you're trying to see how many of them like dogs or how many of them don't. You're trying to take person them and ask how whether they like dogs or not and stuff like that. Let's say you take one person and ask them whether they like dogs or not. The chance of this dude who getting liking dogs is 5 out of 10. Let's say you asked one dude, you asked the person, he liked dogs, and you now take him out of the sample. Now 4 of them like dogs and 5 of them don't. So the chance of getting another person to like dogs is 4 out of 9. See how the probability of success is different now? So this cannot be considered as a binomial because the probability of success is different. But there's one exception. And that exception is if it's a very big sample or a whole population, let's say a million people. And if you take one person, the chance is technically being reduced, but the number is so big but that it doesn't even matter. Now let's talk about neat new formulas for a binomial. We've talked about the mean in this channel, but if you're going into binomials, the formula for mean is now different. The mean formula is this. This is a symbol of mean, n and p, where n is the number of trials and p is the probability. So let's say you're flipping a coin and you want to see how many times you get heads. And let's say you're flipping 100 times. The probability of getting a heads is 50%. So let's take the formula over here and let's replace n and p with the numbers we have. And after doing some simple math, we find that the average is 50. So the average number of times you might get a heads is 50. And that makes sense because there's a 50% chance. And if you flip 100 times, the average number of times you get a heads is 50. That makes sense. Now let's talk about the variance. What is the variance actually? I'll come to that in a second. But this is the formula of the variance. This symbol and 2 right here basically means to square. I couldn't find the square, so I'm just using that. That's also considered square. But this symbol right here in the front, you might actually find it familiar because that is actually a symbol of the standard deviation. And the standard deviation is basically just the square root of variance. The variance and standard deviation actually give the same information. The standard deviation and variance basically both show how spread the data is. If you want to know more about standard deviation, I've made a video about standard deviation already. I'll put that in the description too. But standard deviation shows the spread and variance shows the spread. The only difference is that standard deviation actually shows it in the same units. So let's say you talk about centimeters, the standard deviation actually shows the centimeters, the difference in centimeters. Let me take an example. Let's take the heads example again. And let's put the n and p on top over here. This is the formula. So after replacing with everything and doing some simple math, we found out that the variance is 25. And keep in mind, this is not 25 heads because it's not the same unit. So we have to square root to find the standard deviation, and that's 5. So now 5 heads is the spread. So if you want to know more about standard deviation, it's in the description. But what standard deviation basically is how much it's likely to vary. So from our previous mean, we found out that it's the mean is you might most likely get 50. If you have 100 trials, there's a high chance that you get 50 of them as head, but there's a chance that it'll be 5 higher or 5 lower because that's the point of the standard deviation. It shows how much it might vary. So 5 is the standard deviation. But one important question you might have is, I've been showing you the number of trials and probability a lot, but what is probability and how do you actually find probability? What is the formula for it? This right here is the formula for probability. It's actually not as complicated as it looks, but I'm still not going to be explaining this in this video because you usually do not actually need to understand this. There are computers that can solve this for you. So I'm gonna end off the video here with this formula. I hope you found this video informative. If you have any questions, don't hesitate to leave it down in the comments below. If you have any suggestions or any way I can improve the channel, please leave that down below too. And if you want to see more videos and statistics like this, check out the playlist or subscribe to the channel. I'll be uploading every week. Thank you very much. See you later.